Yes, hello friends. So this would be the video tutorial for Starters 206 on CodeChef, which was held last night. And yeah, sorry for the delay in making the video. I was not able to solve the question number D here, so had to solve it in today's morning. And yeah, we'll record this video for all the five problems, so A to E. So overall, the contest was good. The A to C problems I think are very simple, and then the question ramped up on D and E. And yeah, I think D is a bit harder than E, but again, depends on you guys, what you have practiced in the past and your like strong topics, that kind of thing. We'll also leave the timestamps for all the problems discussed in below, so you can jump to the question you want to watch. And also we'll leave the descriptions of the all my codes in the description again. So yeah, let's start with the first problem. So what the first problem says is, Chef has an integer array A of length n such that AI is 1, 2, 3. This is why the question is very easy, because the limitation on the values of the array. Chef is wondering how many pairs exist in the array which have a prime sum. Formally, the number of pairs I to j such that I is greater than j and ai plus aj is prime. X is a prime number. We all know what a prime number is. Input format is fine, and the constraint here is t is 100, n is 100. Do note that even though, like, we'll draw this here, t okay, sorry, uh, t is less than 100, n is less than 100, but you cannot go n square. You will say, okay, I can go n square. The n square would be just 1e4, right? But this is wrong, because it would be actually n into t square, because for each for one test case together you are solving it in t into n. This is important for these contests, because this t into n has to be considered as a constraint. So actually your constraint on t n is 1e4, so that's why you cannot go n square, right? N square is not allowed. So for all the questions, I think this is to be noted, that the guarantee on the sum of t or n overall test cases is not given. A lot of questions you will see this guarantee given, that the sum of n into t would not exceed around 1e5 or 1e3 or 1e4, whatever the question says. But here it is not given, so you have to calculate that constraint on t on n into t, that is 1e4 here. So you cannot go n square. Okay, that's fine. We can solve this in n time. There's no problem. So yeah, we can see he and rather in this case here, 2 1 3. So for this array 2 1 3, what are all the prime pairs? So if I pick 2 and 1 here, I will get 2 plus 1 equals to 3. This is prime. Then let's say I put 2 and 3. 2 plus 3 is again 5. This is also prime. Now let's say I pick 1 and 3. 1 plus 3 is 4, which is not a prime, so answer would be 2 here. And I think the answer is 2. Yes. So how do I solve this? The key idea here is using the constraint that AI can be 1 2 3 only. So, oh, sorry, AI can be 1 2 3 only, right? 1 2 3. So, what can be the limit on AI plus AJ? It can be at max 3 plus 3 6, and at minimum 1 plus 1 2. Right. So, what are all the primes? All primes in 2 to 6, because these are the only primes that are possible as our pairs. So, all the primes possible between 2 to 6 are 2, 3, 5, right? All on these primes are only possible in the array. So then what we can do is, let's say for this array, let's say for 1 2 3 2 3 2 1, for this array, if I am at 1, what are all the primes I can get? I can get 2. For that 2 I need 1 here. So how many ones do I have? I only have 1 so I can get 1 prime, right? 1 prime. Then, if I want a 3 prime, I need 2. So, what is the frequency of 2 here? The frequency of 2 is 3. So, 1 plus 3. Now, for 5, I cannot get 5. Yes, I cannot get 5. So, I need 4 here. The frequency of 4 is 0. So, 1 plus 3 plus 0. Right? So, that would be 4. Now, similarly, I can go here to get the frequency. So, what I need is the suffix frequency. Suffix frequency. Right. If I have this, sorry, if I have the suffix frequency, I can solve this. Right. And that is what we did. We can go to the code here. So what we'll do is just calculate the total frequency of every value, like 1 2 3. So 1 2 3. We'll calculate this when I am at x. I will reduce the total frequency of x, total frequency of x minus minus, because it cannot form a pair with itself, and then go over all the primes possible and see how many times we can how many times we can get this prime. Let's go over the code here. One second. Yes. So what I did is create all these primes that I talked about. Only these three primes are possible: 2, 3, and 5. I took the input as n. I calculated the frequency. I created this frequency vector to store the total frequency of all the values that are possible around it. So that is the suffix frequency basically. Then I took all the integers an in this array. So that is what I did, and I also updated the frequency. Now I created this answer variable, int answer equals to 0. As I said, at x value I can reduce the frequency of I, and then go over all the primes and get the requirement. So if I'm like at, if I have, let's say, 3 value and I'm calculating for like 2, I would need a, so 2 plus what is equals to 3. So sorry, rather 3, I'm at 3, right? So 3 plus what equals to 2, so that is just 2 minus 3. Again, minus 1 is not possible here, and that is what we handled in our code as well. So, or if, so I get this required. So what is required to add to my AI, so that I get the p, which is the prime value. Now this requirement has to be greater than equals to 1, of course, that are all the possible, and has to be greater than less than equals to 3, because those are only the possible prime value, all the values that are possible in the array. And then I just added this answer into the answer, because these is how many times, how many pairs I can form with AI that sum up to p. And then finally just I outputted the answer. So I can all just submit this code and see you, and this works fine. So yeah, the time complexity would be O of n, or rather O of number of primes into n, and number of primes here is 3, so that is why it is O of n. So a pretty simple question. We can now go to the next one. Gladiator fighting. There are, and this is the second question or the third question? Okay, this is the second one. They are in gladiators standing in a field. They will fight only one gladiator. Till only one gladiator is left. Just give me 1 second. Yes. Okay. Yes. Oh yes. They will fight only till one gladiator left, and other n minus one gladiators have been defeated. Initially, everyone has a skill factor of 0, but every fight that a gladiator wins, his skill factor increases by 1. So yeah. There will be exactly n minus 1 rounds. That makes sense, because at each round one will get defeated, and we have to go till one guy has not been defeated like in any of the rounds. Each round, two gladiators not yet defeated will come and fight, and one will win. The other will be defeated. The entertainment level of the fight between gladiators is their skill level. XY is x plus y. So that is the sum of their skill values. Note that it is possible. So this is a very important note here. Note that it is possible for the lesser skill gladiator to win. So skill factor is not actually related to the caliber of their fighting. So a lower gladiator can win against us, and it's the bigger skill gladiator. So, what is the minimum and the maximum possible total sum of entertainment overall fights? So, input format is like fine. Output is, again, we need to output two integers, that is the maximum and the minimum sum of the total entertainment. Constraints, again, you have to note this, that we are not solving over n, we are solving over n into t. So, that is 1e4 again for this question. Yes, so how do we solve this? Let's try to dry run this. So let's say n equals to n, which is the number of gladiators, equals to 5. There are 5 gladiators, 0, 0. All have skill factor of 0 initially, right? So this is 1, 2, 3, 4, 5. So this one is not required. Okay. Now let's say if I want to minimize my skill factor, how can I do this? That the minimum total entertainment, sorry. So again, at first instance, you can choose any gladiator. It doesn't matter. Everyone has a skill factor of 0. So you pick these two up. You, when one guy wins and he has a skill factor of 1, other guy loses. Okay. So now you have the array of 1, triple, 0. Now what should you do? You can pick these two, right? If I try to solve this using greedy, that is, at one instance I want to minimize the entertainment that I can get in this right now. So again, if in greedy, what you will do is pick these two guys up. One, one guy will win in these two, so they will have us 1, 1, 0. Right now, what you will do, again, minimize, try to minimize. So you will pick these two, and 1. Now the entertainment till here was 0. The entertainment till here was 0 because we were only summing 0 with 0. Now here the entertainment would actually become 1. Now which guy should win here? Which guy should, if you want to minimize it and you're trying to greedy it, why would you make this guy win? If you make this guy win, you will get 1 and 2, and then the entertainment would be 3 for the next fight. But if I pick this guy to win, he'll get an skill factor of 1, and then the entertainment of the total of the fight would be actually 2. So you should pick the smaller guy to win. So if you want to minimize it, always pick least skill factor to win. Now similarly, if you want to maximize it, pick maximum skill factor to it. And actually it can be like shown here that the order of fights do not matter. So we saw this order, right? And we did this 0 0, and we got the sum as 1 plus 2 here. So 1 plus 2, so total skill here is 3. But you can actually use any amount of, like, any order, but just keep this thing picked. Always pick least skill factor to win. So here we can also like dry run this. So if I pick these two guys up, I'll get 1 0 0 0. Now I can pick actually these two eyes. So 0 0. So and then I will just make sure that the lowest skill factor guy is 1. So that would be 1 here. So the entertainment level of this fight would actually be 1 plus 0. So 1 1, right? And the my array would become 1 0. Again I pick these two guys to win. Again I pick that this guy will win. So 1 0. So that is 1, right? And then I pick these two guys, and this guy wins 1, 1, 1, and 3. So again, I get the answer same. So it doesn't matter, the order doesn't matter, only need to make sure this. So order doesn't matter. So order does not matter. Okay, so yeah, that's fine. So then the question like comes to your mind. Okay, we can simulate this. That I can pick any two guys and do the simulation. If I want to get the minimum result, I will pick the guy with the minimum skill factor to win. Otherwise, I will get the maximum skill factor guy to win. And you can do that. And it will take you off in time because each time you are eliminating one guy. So that for, to get this thing, you will do n simulation. That is fine. But the other thing that you can also notice is you can solve this actually over one time. How you can solve this in over one time is that the minimum answer would be actually n minus 2, and the maximum answer would be sum of n minus 2. So rather, sum of I, so that is sum till I from 1 to n minus 2. So that is like, what is the sum till 1 to k? That is k into k plus 1 by 2. Here it will be n minus 2 into n minus 2 plus 1, that is n minus 1 by 2. So that would be the maximum answer. This would be the minimum answer. Okay, you will say, okay, given me the result. Can you prove me this result? I'll say, yes, I can prove you this result. How can I prove you the result? It's very simple. Let's say I have n guys, right? N guys, 0 0 0 0 till n. What I'm saying in the minimum case is that I will pick any guys. Like the order doesn't matter, but I will pick the guy with the least skill factor. So let's say I do the first simulation. I pick these two guys up, and I say that that any one wins doesn't matter because both of them have equal skill factor, right? 1. So the entertainment that I get till now, 0 plus 0 is 0. Now I pick this guy and this guy to fight. I again, my entertainment would be 1 plus 0. So yes, so let me do this. This will make more sense. So let's try run this again. I will make this better to understand. Okay, so I have n guys, 0 0 0 till n. My total entertainment is here. Total entertainment, which is 0, like nothing now, right now. So I pick these two guys to fight. These two guys fight, and I say anyone wins, doesn't matter. Both of them equal skill factor. So these two guys fight, and I get a 1 skill factor now. I say this and this guy fights. So now my total entertainment would be 1 plus 0. So that would be 1. And the one with the skill factor of 0, I will say that that guy wins. So 1 0 0. So again I do this again, and then I get a 1. Then I get a 1. So how many times does this thing run? This runs actually n minus 2 times. Why n minus 2? We can like see here also that for n equals to 5, for the first round I got 0, and for the next 3 rounds I get 3. So that is why this is n minus 2. N minus 2. And you can actually prove this, that you will have to do n minus 1 fights. For the first fight you do not get any sum. So for n minus 1 minus 1. So n minus 1 is total fights here, and the for the first fight the sum is 0, because you are doing a 0 plus 0. So that's why the minimum is n minus 2. Why is maximum n minus sum of n minus 2 is, you can do this again, the same simulation, but now you can try to make the the maximum skill factor guide to win. What will change here is, say we try run this again, 0 0 0 0 tell n. Rather, let's do one thing. Let's not generalize it. Let's solve it for n equals to 5 only. So 1, 2, 3, 4, 5. So in the first round, 0 and 0 guys, right? Doesn't matter who wins. I'll just put a 1 here, right? So I total entertainment is 0. Now my 1 plus 0 wins. So, and I say that the 1 guy wins. So 0 plus 1. So that is why 2. Right, when 2 and 0 fights, the entertainment is 2, and I say that the 2 guys win. So the 2 skill factor guys win, because I want the maximum skill factor guy to win. So it becomes 3, then 3 and 0 fights, and then I say that I again 3 wins because he has the maximum skill factor. I get 4, and this fight and the entertainment for this is 3 plus 0, so 3. So we can see that this is just the sum till n minus 2. This is just sum till n minus 2. Okay, yes, until n minus 2. So hopefully the explanation and the proof makes sense here. Some of Yeah, we can now go to the code. All we did in our code is, this is problem number 4, I think, for me. Or rather, did I mess this up? Problem number 2. Okay, it's problem number 2, sorry. So yeah, I took the input as n. I calculated the maximum. As I said, this is just the sum of till n. So sum till n for n minus 2, and minimum would be n minus 2, and I just outputted it, and I can show you that this works also. So yes, hopefully this makes sense. So yes, this works. Let's go to the question number 3 now. Question number 3 is a bit of an intuitive problem. If you get the intuition, you will solve it very quickly. Otherwise, you can go and like keep going till you find the proof of this. Okay. So what the question says is, permutation P is of 1 to n of size n. Okay, so permutation. What is a permutation? A permutation is nothing but an array of size n. So P here of size n, which can only have 1 to n, and each value should be once. Should be once. So that means should be once, and it is of size n. So it has to be an arrangement of integers from 1 to n. It could be like 3, 2, 1, 4, 5 for n equals to 5. This is a permutation, but if it is 3, 2, 1, 4, 4, it won't be a permutation because 5 is not there. So, makes sense. I think you should know what a permutation is. So that's fine. This is a question on a permutation. So we then define fp as the number of fixed points. That is number of I such that pi equals to I. So the number of fixed points here would be, if I go over the indexing using one based indexing. Okay, why does this not work? Okay. So this would be 1, 2, 3, 4, and 5. So this is a fixed point because pi equals to I here, pi equals to I here, and pi equals to I here. So you have 3 fixed points. Make sense? Yes. Now a cyclic shift. So we should all know that what a cyclic shift is. It's just shifting this array once. So shifting this array once to the right would be, you'll get 3, 2, 1, 4, and 5 would become at the front. So this is one cyclic shift. Again, you can do the cyclic shift here. Right. So the second cyclic shift would be that 4 comes again, 4, 5, 3, 2, 1. All right, makes sense. What a cyclic shift is. So what the question says is a cyclic shifter. This is what we know what a cyclic shifter is. Define f gp equals to maximum of fq over all q, which is a cyclic shift of p. So let's say I have p here, P is a permutation or even an array, how many cyclic shift does it has? It has actually n cyclic shift, because the n plus 1th cyclic shift is actually same as 0th cyclic shift. Rather, I think even the nth cyclic shift we can write than this here. And if I have 1, 2, 3, let's say this is the 0th cyclic shift, because we haven't shifted it even once. The first cyclic shift would be 1, 2, 3. The second cyclic shift would be 2, 3, 1. And the third cyclic shift would be 1, 2, 3. So the nth cyclic shift is same as the 0th cyclic shift. So P has only n cyclic shift. Okay. So Q is the set of all cyclic shifts. So Q is all cyclic shifts of P. And the question says is that we have this, we want to minimize the maximum value of FQ. So for all the cyclic shifts of P, we calculate the maximum value of the F and we want to minimize this. Construct a permutation of size n which has the minimum value of GP among all permutations of size n. Okay, so you have to create a permutation of size n, which for all the cyclic shifts of this permutation, the maximum of number of fixed point of this is minimum. I think it gets a bit wordy, but I think you should be able to understand. We'll again go over the constraints. Again, you have to note that you have to solve it over n into t, which is here 500 into 500. So that would be 1e4. So 2.5 into 10 to the power 5. So yeah, again, you can go n or n log n. Root n I think should work, but again, you don't need to do that. This is a simple O of n construction question. So how do you construct this array? Let's say if you want to like you, so when do we get the minimum amount of fixed points if you have this array, right? Of size n. Let's say 1, 2. This is the index in the array. 1, 2, 3, 4, 5, 6, 7. Like this, you have to construct a 7 array. So when do we you get the minimum amount of fixed points? So the minimum amount of fixed points you can get is like you can like swap every value, right? You swap 1 and 7, you get 7 here. You put 1 here. Then you swap 2 and 6. 6 comes here. 2 comes here. 5 and 3. So that you will get 5 here, 3 here. But you will say, okay, this is an odd, so 4 would come here and you will get one fixed point. But again, you don't need to do that. You can actually swap this two also, 4 and 5. So you will get 0 fixed points. Okay, so you say, okay, for one cyclic shift, I am getting 0 fixed points. But what about the next cyclic shift? So for one cyclic, you get 0. But for the next cyclic shift, if I put 7, 6, 4, 5, 3, 2, 1. Now the fixed points would be 1, 2, 3. So I'm getting 3 fixed points. Okay, that's a lot. I think we can minimize this. How can we minimize this? So this solution that we came up with is actually not reliable. Not reliable. Not reliable over all cyclic shifts, because we saw that okay, we were getting 0 in one cyclic shift, but again doing the next cyclic shift, I'm getting 3. So how do I get a reliable solution? So you can think about this, that how should we proceed so that overall cyclic shift this value becomes minimum. Let's see what the minimum answer can be. So if I ask you what is the minimum answer here, minimum answer is basically the minimum fixed points you can get. Can you get 0 fixed points? That is a like bit optimistic on your part. Can we get one fixed point? Why I'm saying is that we that 0 is not possible. Is because let's say we have this array, right? Like any size of array, one, like any arrangement of this P permutation, like P can be like 3, 2, 1, 5, 4. Right? You will say right now it doesn't have any fixed points, right? But when we shift these values, at some point 3 would come to 3, right? At minimum, in one of the cyclic shifts, 3 would come to 3. At another cyclic point, 2 would come to 2. Like even the 2 is here. So we can do this 1 and 3. 1 and 2 rather. 1 and 2. So now it has 0, 6. So at one of the cyclic shift, 3 would have to come here. One of the cyclic shift, 1 has to come here. So that is why 0 is not possible, 1 is possible. and 1 is the best answer that you can get. How you can get 1 is just reverse the array. So rather than for 1 for 5, you will get 5, 4, 3, 2, 1. So why this works is, again, this is what I meant by intuitive. If you got this approach very quickly, you can solve this very quickly. Like I got this approach in like 5 minutes, so I was able to code it out and submit it in around like 6 minutes. So why this works is, right now, how many fixed points do you have? You have only one fixed point, that is 3 and 3. Now if you shift this, how many fixed points will you get? You will, if you shift this, you get 5, 4, 3, 2, 1. So you get one fixed point. And this would actually make sure that you always get one fixed point. And it doesn't matter the sum, it only matters that the maximum. So maximum would be 1. So if you again like try to do another shift here, 5, 4, 3, what is here? 2 and 1. Now this becomes a fixed point because 4 is at 4. So every time only one cyclic shift would, only one fixed point would be there over all cyclic shift. This also works because you can see that why this reverse the array. So at max you will get one fixed point here. And you can also think about why we are only getting one fixed point here is it's a like kind of biatonic array, right? It increases, then it decreases. And like it's fine. Like if you get got this intuitive, I can prove this, but it would get a bit lengthy. So I'm skipping the proof here. But hopefully like you can try run this more and see that this works. We'll jump to the code here. It's a pretty simple code. So all you need to do is just take the input n, and for each integer just output n minus 1, so that n minus I rather. So that is what you're getting, the reverse of the array. Okay. Question number 4. So this is an interesting question that I wasn't able to solve during the contest, but after the contest and reading a bit of editorial, I was able to do this. It's a pretty mathematical question here. So yeah, let's jump into the question. You start with an integer x equals to 1. It's a pretty simple question in the understanding of it. In each step, you can do exactly one of the following: multiply x by 2, add d to x. Okay, makes sense. Find the maximum number of steps you to make x equals to n. So if you are at 1, so if you are at 1, you can either go to 1 plus d, or you can, or rather, let's do it generic. Like you are at x, you can go to x plus d, or you can go to 2x. Like these are the two options you have. And the minimum number of steps to make x equals to n, it is impossible, print minus 1. Okay. So if you solve this question and if you have done any amount of BFS, you will see, okay, I can just do a simple BFS. Won't take too long. It would take like off in time, but the question becomes interesting when you read the constraint. N is as large as 118, and also you are not given any constraint over sum of n. So again, you will have to solve it over n into d. So that is 10 raised to the power 21. That is a huge amount of number. First line of input would, and the input output format is fine. So how do you solve this thing? You can do any amount of BFS. A lot of people would think about their optimization of rather going from 1 to n in BFS. Rather than doing that, you can go from n to 1. So how would we change the operations if n mod 2, that is basically even? You can go from n to n by minus 2, and you can go to n by n minus d. Else, that is n is even, n is odd, you can only go from n to n minus d. You can do this optimization and get the minimum answer for 1, but again the problem is that it would TL. I did a lot of optimization during this contest of trying how to save this TLA. I was not able to do this. So any BFS question, any BFS like method would TL. If not BFS, then how is the question? And then you have to come to mathematics. Like your algorithm doesn't work, so you have to make your own algorithm. How to do this is the question. So you have to go from 1 to n. Let's say that how what are the possible operations you can do. Let's say you can do into 2 and the plus d. Right? These are the two operations. Let's say at 1 you do an into 2 a times. So if you do it a, sorry, rather let's say you do this b1 times, or rather let's say Let's say you are at this point, you are at 1 and you do a adding d operation a times a1 times, so you will get 1 plus a1d. Then you do an into 2 operation b1 time into 2 b1. Again you do up, so a2 operation d times. Why I'm saying is that you cannot do any amount of into 2 more after, like you do into 2 b1. If you do again into 2 again, so into 2 b2 times, that is same as saying into 2 b1 plus b2, right? So it's same, like this and these are both variables to us, we don't know the values. So that is why we are taking alternating moves. So alternating between addition and multiplication operation, right? So plus a2d into 2b2 and so on. So what would this actually reduce to if I want to solve this? I tried doing this during the contest, but I got like a bit messy for me, and I thought, okay, the solution still didn't come out of this, but it came out of this. So yeah, bit unlucky on my part, but that's fine. So 2b1 plus a1 2b1d plus a2d into 2b2, right? So I just did this multiplication here. And then I do the multiplication again. It will become 2b1 plus b2 plus a1 2b1 plus b2 d plus a2 2b2 sorry 2b2. Let's say I have more terms here, right? That's more terms. So I can, like, I can see the pattern even from this thing. So if you want, you can add a couple of more terms. The final answer, if I like, would come to is that here all the factors of b1 will add here. So it would become 2b1 plus b2 plus b3 plus dot dot dot. So sum of all b's plus I take the d common here. So plus d here. And this would be a1 2b1 plus b2 plus dot 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 plus a2 2b2. So now the a2 term starts from b2. So 2b2 plus b3 plus dot 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 plus a3 2, it will start from b3 plus b4 dot 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 and plus dot dot dot. So this is the final operation that I want, and this should be equal to what? This should be equal to n, right? This should be equal to n. So this all has to be equal to n, right? And what is the total operations that I'm performing? So total operation or total moves would be actually, like, see, we do b1 multiplication, or rather we do a1 addition, then we do b1 multiplication, then we do a2 addition. So it would be a1 plus a2 plus dot 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 plus b1 plus b2 plus dot dot dot. That is sum of a constant, and sum of the b, sum over b. So that is the total moves, and we want to give me a second. We want to minimize this. How do you do this now? If you know this expression, you can guess. Like if you get to this expression, I think you can guess the solution, or you can come up to the solution. The thing here you have to see is this factor. Sorry, let's do this. Okay, you have to see this factor. So this is a pure 2 to the power factor, right? So it becomes something like this operation. I can reduce to like 2 to the power k plus d into some variable x. It has to be equals to n. Okay. Now n is can be as large as 1e18. So k, can I say, would be around 60 or 64, even if you take 64. So 2 raised to the power 64 is beyond even LL max, I think. And LL max is much larger than 118. Okay. So I can go over all k. Go over all k. Now I would, so my dx then would be, has to be equal to n minus 2k, like for 1k. for k in 1 to 60 or 1 to 64. Let's keep it at 1 to 60. So my dx has to be this. So what would has to be my x? My x has to be n minus 2k by d. That is n minus 2k has to be divisible by d because x has to be an integer. That makes sense. So I get this value x. I get this value x. Now what is my k here? My k is the sum over b, right? K is this thing. So my moves was sum over b plus sum over a. Now I know my sum over b, which is k. What is the now I want to minimize my moves for 1k. So what has to be minimized now is sum over a. So sum over a has to be minimized, and that is given by x. Because x is what? X is this sum, right? A1 into this. So yeah, the solution is a bit messy and a bit more mathematical than a normal competitive programming question, but that is fine. Like you have to deal with this maths question. Okay, so x is what? X, you know the value. X is some like variable. Y, we know this value. Now this y has to be what? It has to be a1 into 2 raised to the power k, because k is what? Sum over b, and the first factor here is this one. So a1 plus a2 2 raised to the power k minus b1 plus a3 2 raised to the power k minus b1 minus b2, like this kind of thing. So for this condition to be true and we want to minimize sum over it, how do you do this is that if I know k and I know my y, this is a greedy solution. So what's a greedy here is that you should actually pick as many 2 raised to the power k, then as many 2 raised to the power k minus 1, and so on. So what I mean by this, if let's say y is let's say 10 and k is let's say some 3, so you will have this like a1 2 raised to the power 8 plus a2, and now I'm assuming that my b1s are all 1, so that would actually lead to the best solution. You can think about why we can do this assumption of b1s all b's equals to 1, but that is why it would lead to the best solution. Like the best way to think about this solution is actually assuming that each a1 is like this 0 to 1, and each b1 is this 0 to 1, this thing. That is why I think this is a maths question more of a competitive programming question. So so this would be a2 2 raised to the power 4, or rather 2 raised to the power 3, 2 raised to the power 2 plus a3 2 raised to the power 1 plus a4 2 raised to the power 0. So how many? Rather, let's do one thing. Let's change this to 24. So how many? 8, 26, 8. So how many times you should even should be equal to 8 divided by 26? That is 3. Then you will get that 22 should be equal to this sum, right? And that would be just a2. You cannot pick any, so because 2 by 4 is 0, 2 by 4 is 0, you cannot, a2 has to be 0. A1 we get as 3, then a3 would be 1 because 2 by 1. Let's go to the code. I think you will understand it more in the code what I'm saying here. Yeah, I took both the n and d values as ll. I created this answer as long max. Why long maxes? Finally, if I get that my answer is still long max, I should just output -1 here. Otherwise, I can output answer. Okay, so what I go over all the powers of 2 that is possible. So that is this thing, right? That we did here. So 2 raised to power k. So that is the power of 2 variable that I'm creating. Okay. So my requirement is n minus power by 2, n minus power 2, sorry. So like for 1, for power 2, so for 2 raised to power k, if k is equals to 0, this would be 1, then it would be 2, so it would be n minus 1, then n minus 2, then n minus 4. Hopefully this makes sense. Now this requirement has to be divisible by d, as we saw in the mathematics there, and if it is not, then the answer cannot be possible. So that is what we do. Then this if block. Okay, so if this is divisible, what is the requirement from us? So this x variable is actually this y that we saw this. So yeah, sorry for that miscommunication. So yeah, this is this. So this is this y, or rather, we can say this is that x. Okay. Now, C answer equals to count. So count is the power that we have. So 2 raised to the power what here? So the count is initialized as 0, and at each I'm just doing count plus plus. And power 2 equals to power 2 into 2. So how do I get the maximum, like the minimum thing here? Is C answer is count. That is the current answer. Then I go over all the powers of 2 that is possible. So if I'm at, if this is 2 raised to the power count, you will have plus d into a1 2 raised to the power count plus a2 2 raised to the power count minus 1 plus, so all of these powers I can have any amount of time, plus a3 2 raised to the power count minus 2. Hopefully this makes sense. So this would reduce to x equals to a1 2 count minus 1. X is here n minus 2 count divided by d, plus a2 2 count minus, or rather this would be this count minus 1 plus a3 2 count minus 2. Hopefully this makes sense. And what would be the minimum of sum over a? We saw this using the greedy solution. So what is the greedy solution? If I pick f amount of times, that is x divided by val. So I am picking a in this power f times. So c, I would have to add it into c answer, and then I would reduce from this from x here, and then just do answer equals to minimum of answer comma c answer. Yeah, I don't think this is like the best solution or the best understanding of the solution you can get. You can like read through some editorials and all of that, but I think what would help you the most is actually try to solve this, like get to the mathematics part and then see, okay, we have to go over all the powers and how do I minimize this sum over a. So yeah, sorry if the solution got a bit messy, but the problem is messy. It's not my fault. At Like it's my fault to get this make the solution messy, but I think the solution anyhow would be messy. Okay, the final question, which I was able to solve during the contest, and I was proud of able to solve in this question. So what the question says is an array of length A is an array of length n is said to be good if the product of the array has to be equal to the sum of the array, as it is product equals to sum. Given an array A of length n, count how many subarrays of A are good. Formally find the number of pairs L2 are such that that is fine. The array is good. The subarray from L2R is good. Okay. Constraint. So this is like the normal pattern that you see, that you're given the constant n and you're also given the sum of n. Overall test cases do not exceed 2e5. AI is 1 to n. So how do I solve this question? Whenever you see product, you have to see the pattern that the product, like if I'm doing a product here, a1 into a2 into a3, this product actually grows very large if ai is greater than or equals to 2. What I mean by very large is actually 2 raised to the power 60 is 118, right? We saw this in the last question also, is around 118, not exactly 118, right? 118. So if all these ai values are actually greater than 2, you have to only consider a window size of 60, because the total sum of the array, like how much maximum can the sum of the array actually go? Like this is the mathematics that we know, right? Let's paste this here. Okay. Why did this come like this? Okay, it's fine. So you know that a1 plus a2 plus dot dot dot, or rather let's keep it like for the subarray. So al plus r, al plus 1 plus ar equals to al into al plus 1 dot 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 ar, right? Now this thing can have at max value of total sum, right? total sum of the array. What is the total sum of the array bounded by? The total sum of the array would be like at max n into n, right? If all the values are n, so that would be n square. So this is actually 2 into like uh, total sum can be at max n square, which is 4e10, or you can 4e10. But this value can go very very large in small arrays only. If, like, assuming if AI is r greater than 2 or greater than equals to 2. So for this, like even 40 or 50 like size is fine. So why this is important is, and how this helps us is that if I want to count the number of subarrays in starting from AI, the maximum window that I have to consider is only like 60 or 50 or very small. I know that if all the values were greater than 2, I'm assuming this thing here, we'll go back and see how that, because it's not guaranteed that all the values would be greater than 2. It is great given that AI can be from 1 to n. So that is how the question, if the question was that all AIs would be greater than 2, how we would solve this is that for I will keep the window size maximum of 60. For each index, I have to only go till I to I plus 60. Calculate for each point in this in between point. We calculate the sum. We calculate the product. If it is equal, do answer plus plus and go on. And what would be the time complexity of it? For each index, I'm doing 60 operations, so it would be 60n. And 60n is like for n equals to 1e5, it would be 12 into 1e6. So that is very handleable. So this is fine. So if we saw how to solve this question, if all the values were greater than equals to 2, but that is not the case. So how do I solve this? The problem here occurs is because we have 1 here, the maximum window size could be anything. Why? Because let's say if I have an array 2, 1, 1, 1, 2, 3, 4, right? So the total sum here is 4 plus 2, because that total sum would actually bound the product, right? If the product at any point goes beyond the total sum, there cannot be possible that the product and sum of the sum array becomes equal. That is the first assumption that I'm making. Or the first like thing that I will use to solve this product. So total sum here is 4 plus 2, 6 plus 7, 8, 9, 11, and 14. Total sum is 14 here. Now, why this makes sense is like if I have total sum 14, I will say that okay. So why this one makes a difference is because in if you're doing a product into one, product would remain same, but if you do a sum would increase. Sum plus one. So now this that the maximum window size can be 60 becomes false, because if you have a lot of ones, then all those ones can come up. The product would remain same, but a sum would increase. Like hopefully this makes sense. So you cannot bound the maximum window size by 60 or 100 or any constants. So how do you solve this? Can I say that even if if okay, so how do you solve this? That I know that uh, if I'm at I can go till any point till my product is less than total sum of the array. Right? Till this is true, I should keep on going. If you like do this solution only, so what I mean is you just start at I, then you keep going till the point till the product is less than the total sum. You will get TLE because that could go up till n square. Will it go to n square or will it actually sum back? You can try this out. You can use sliding window here. I think it would TLE. I will go with my solution here. I won't try to see if the solution would actually work. But I think they should TLE. This should TLE. Because if there's a lot of ones, the product would remain same and the window size could be very large. How do you solve this then? The key here is to compress the array. What I mean by compressing the array is because see, the ones can be like any times, like one can be any amount of time, it can be k amount of time, but non-one values can actually be less than 60 or less than 50, a very small value. So non-1 values have to be very small. So how this compressing the array, and what this means is, if I have this array 2 1 1 2 1 1 3 3 2 2, I would actually compress this array as 2 comma the frequency of 2. So 2 happens one time, then 1 here, and the frequency of 1, that is this subarray 1 comma 3 3 comma 2 and 2 comma 2. Why this is helpful is, see, now in this array, how many terms can I pick? Is this how many terms that I can pick bounded or not? So we saw that for the all for the array, the number of terms that we, if without compressing it, the array we can pick any amount of terms because there is one occurrence here. Like the one can come, that doesn't like increase the product very much. But after compressing the array, you can actually say that this is very less. Like this is less than 100. Why? Because see, one term would have one, so the next term cannot have one. So this doesn't have one as consecutively elements, right? So if you have like, let's say maximum terms as 100, at max non ones has to be on at minimum, sorry, at minimum, non one has to be 50. So non ones has to be 50. That is fine, and that is what we said here, right? That one can occur any amount of time, but non one elements has to occur 50 times. So if you compress this array and now try to solve it, you can actually solve this and not get TLE. So not get TLE. So this will pass. Okay, why does this not work? This will pass. So what the question now comes up to, you go to the array, you compress the array. Now at each index, you go over all the compressed array and see at what point your product and sum are equal. Right? That makes sense. But how do you go over the compressed array? You cannot like go over each element. Like let's say you have this array, right? 2 1 1 1 3 2 2. The compressed array is 2 1 1 3 3 2 2 2. So this is element comma frequency basically. Now let's say I start from here. I know that on the compressed array I will only go a maximum of very small amount of terms. So 2, then I say okay, I am at this term. So can I go over all the, so how do I go over this term? My product till now is P equals to 1, my sum is 0, right? Let's say I have any element X which has a K. So this is the term I have right now. So when would this be equal? So I have this term and X occurs K times in the compressed array. And I have this product beforehand, sum beforehand. Let's say at some point, at some L, these two becomes simple, these two becomes equal. So what would be my product now? Product will have xl times, so p into xl has to be equal to sum plus xk, sorry, sum plus kx, sum plus kl rather. So I'm picking xl times and I'm saying that at this point these two have to be equal. So p into x raised to the power l has to be sum plus k into l. So we can use the bigger L notation. That is fine. So let's do some maths. Again, this question comes up to maths. So this would be not k, this would be x. Yes. So what you can do now is move the sum here. Yeah. So this would be sum minus product, or rather, what you can do is, okay, we can like go with this expression. Fine, is fine. Now again, if x is greater than equals to 2, I will say that on increasing my L, my P into XL would increase very very large, and my sum plus XL would become large but not as large. Okay. And my product is always greater than equals to my sum. At any point, my product would be greater than equals to sum. So if the value is not 1, you cannot catch up. Right. So I know that my product, it doesn't actually have to be equal. Okay. Yes. P into XL would actually increase very very large and simplest XL. Okay. So what I can say is, let's say I can do a binary search. Binary search. So what I'll do is, like, I know that that the number of times I can pick this term x can be from 1 to k times, right? I can either pick them one time, or I cannot pick. I can pick all of them. If I can do a binary search, I get to this point L, and I see that if this is greater, I should reduce my. I should try the this second half. So that would be 1 to L minus 1, and so on. So this can be solved using binary search. I will show you how. Now the other thing that you need to make sure, if x equals to 1, what would this expression reduce to? So p into 1 raised to the power anything is p, and sum plus L. So our L would actually become p minus s. I'll show you the code. It would make more sense than my explanation does. Okay. So I took my n input, I created the vector L, I took all this input, I got the total sum. This total sum would be useful for seeing when the product becomes very large and we cannot get the array. I accumulated all this thing, and then I created this compressed array. This compressed array is in the form of pair LL comma LL. The first one having the value, second one having how much frequency that occurs continuously. So compress, we can see this compress function. Compress. What we do here is get the a dot size, create the answer variable. We push the first element, and for each next element, we see if it is equal to the last element. We do the last element's frequency plus plus. Else we add it to the answer variable, and finally return this answer. So hopefully this compress makes sense, and how we do the compression also makes sense. Then we go over all the integer arrays for all the starting indexes. Now all these single elements would have the answer, right, would actually be valid, like for any one element array. So x comma x, x comma x, so this has the sum of x only and product also x. So this array basically x, so this has sum of x, p of x. So all single element array has the product and sum equal, so that's why we do answer plus plus, and we reduce this from the compressed array. So we got the top, the front of the compressed array, and we do the frequency minus minus. If the frequency becomes 0, then we just reduce, then we just remove the uh, top of the compressed array. Now we create a product and sum. Now we go over all the terms that are in the go to the all the terms in the compressed array. At any point, if the product becomes greater than total sum, we saw that now we cannot get the answer because product would always increase, and at max, the sum of the sub array could handle ts, total sum of the array. So if this becomes true, this breaks, and this is why we are not actually doing n square computation. We could get the term that we have if x is, if the x is 1, so we saw the y would be product minus sum. So y is at what point in this 1 to f is it equal to the product and sum are equal. So we saw this, right? If y is 1, L would be p minus s. Makes sense. Else we'll do the binary search here, and I can show you how we do this binary search. So get y, the L is the starting point, so L we are given as 1. So how many times we of this x we can pick at minimum, and this is at maximum how many times you can pick. So L and R, I calculate the M, I get the product. So on getting this product, you have to be careful to use a safe multiplication kind of function. Why? Because multiplication can overflow or even over long max. As I said, product grows very very quickly, and you are doing a product over n terms, so that could be like n raised to the power n, so that becomes very large. That's why you have to do the safe multiplication. What the safe multiplication does here is just it will check if this multiplication will overflow. How it does that? If one of the values, so you can see here we just did, I wrote this using AI, I won't lie. So yeah, that's fine. I just do that. A should be great is A into B should be less than long max. If it is not true, I just return true. And then I do, if it will overflow, I return long mass, else I will do the actual multiplication. So that's what we do. We get the x raised to the power mid here using the exponentiation function. I think we should, if you're looking at e solution, you should know what exponentiation this does. And I get the sum here. So at, if you add this m times, so you will sum will be sum plus x into m, and your product would be product into x raised to the power m. So that is what we do here. If product is same as sum, you return m. If it is so this is the valid point. If it is not the case, so you reduce the range, and hopefully you get this y point. Now after getting this y point, you need to check if this y point is valid. So y should be greater than 0 and less than y and less than f, because you can pick either 1 or at minimum 1 times this x element, or f times. So if this is the case and this is valid, you do answer plus plus, and if it is not, you remove, retain the answer as it is. Then finally you do, like you have you, if you are at this term, and now you want to see at what term in the next thing the product and sub can equal. So this product would be same, this product has to be in the array, right? So that is what we are doing. You are picking the whole term in the product, so safe multiplication of product into exponent. So again, product into x raised to power f and sum plus x into power f. So, and then finally just shouting the answer. So we'll submit this and show you that this works. This again is a very complex solution. I think there are easy solutions. Okay, I got compilation error. There was something already written there. Why? Why is this an I here? I don't know. So, is this I here also? Yes, it is. Yeah, this works. Yeah. So that's it for the video tutorial. Yes, the D and E solutions were a bit tricky. Thank you for watching.